Welcome to the name reaction series. Today we are going to see the Jones oxidation. In Jones oxidation, it is an oxidation reaction where alcohol are converted to either ketone or carboxylic acid. Depending upon the substitution, we may end up in the ketone or acid. When the oxidation is carried for the primary alcohol, we get the carboxylic acid, and when it is used for the secondary alcohol, we get the ketone as a product. So as discussed, this is Jones oxidation, and Jones oxidation uses the common name reagent, that is Jones reagent, for the oxidizing an alcohol. As told earlier, primary alcohol are oxidized to carboxylic acid and secondary alcohol are oxidized to ketone. Let us see some of the applications of Jones oxidation. Jones oxidation is used in synthetic organic chemistry to prepare a carbonyl compound such as ketone and carboxylic acid. It can be also used for the preparation of intermediates such as ketone and acid, which are used in reaction sequence for preparing a more complex organic compound. And it can be also used for the analysis of alcohol. So when alcohol is reacted with a Jones reagent or Jones oxidation condition, the product form can be aldehyde, uh, can form ketone or acid. When product is ketone, then there is a presence of secondary alcohol in the sample, and when there is a carboxylic acid form, then there is an primary alcohol in a given sample. So this can be effectively used for the analysis of an alcohol. Let us see the mechanism of Jones oxidation. The mechanism of Jones oxidation. So in Jones oxidation, there are two key steps. The first one is the formation of chromate ester intermediate, and the second is the elimination of an ester to form the carbonyl compound. Let us see the mechanism. This is one of the examples. Depending upon the starting material such as alcohol, primary alcohol or secondary alcohol, we may get the ketone and carboxylic acid as a product. Let us investigate the mechanism in detail. In the first step, there is the attack of this alcohol OH on the chromic oxide. In the next step, there's a proton transfer from this OH to a chromate anion to generate the chromate ester. This is a chromate ester and it is the key intermediate in the Jones oxidation reaction. In the next step, there's a proton abstraction using the water. So this proton is abstracted and there is a carbonyl bond formation between the carbon and oxygen, and this chromate is displaced. So when there is an secondary alcohols. So both are the RR and there is no proton present. We get the ketone as a product. When there is a presence of proton in this reaction, when we use the primary alcohol, we may have a proton. So this proton is further converted to acid. Let's further continues the mechanism. In the second step, there is a protonation followed by the attack of a water molecule to generate the diol. This diol, one of the alcohol, attack on the chromic oxide to generate the chromate ester. And this chromate ester is similar to the first step. The proton is abstracted to generate the carbonyl bond between the carbon and the oxygen. So we get the carboxylic acid and the chromate dichromate. So, depending upon the starting material, we may get the ketone and the carboxylic acid. So, there are many advantages of Jones oxidation reaction. The first one is the high yield. So, the yields in Jones oxidation reaction are generally high, and the reaction time is less as compared to other oxidizing techniques. The reagent used, that is chromic oxide, is inexpensive and it is what you call as it is highly inexpensive and low cost. So these are the two major advantages of Jones oxidation. So there are other two main disadvantages. The first one is use of toxic chromium reagent. The chromium reagent are highly pyrophoric and they are toxic in nature and they are more sensitive to the moisture. And the second one is the can be sensitive to the reaction condition. Since you are using the highly acidic medium, so it is not suitable for the all the functional group present on the substrate. So they are not tolerated in the Jones oxidation reaction. Let us see the scope or what alternate of the Jones oxidation reaction. There are many alternatives for the Jones oxidation. So all they are based upon the chromium oxide derivative. The first one is the pyridium dichromate. It is high. It is useful oxidizing reagent and effectively used to convert the primary alcohol to aldehyde and secondary alcohol to ketone. Another one is the Jones reagent, as we have discussed. There are few more pyridine-based reagents such as pyridium chlorochromate, potassium dichromate, uh, Rat- Radcliffe reagent, Collins reagent, and Scares reagent, and lastly the sodium dichromate. So these are the all reagents based on the chromium oxide, and which is extensively used in the Jones reaction. Thank you guys. Hope you like my video. Please share and subscribe.